Hey everyone, here's a quick video on quadratic equations. We'll set it as equation quadratics. I kind of started out with a quick little example of considering. The question is it possible to have more than one solution to an equation? So if I give you 3 to the power of 2, what does it equal? Well, you know that it equals 3 times 3, which equals to 9. If I said the same, or if I said this, what's negative 3 squared? What does that mean? Well, it's negative 3 times negative 3, which equals, I should just write that a little bit better. There we go. Which equals 9, because a positive times, or sorry, a negative times a negative makes a positive, and 3 times 3 makes 9. So you can see that both 3 to the power 2 and 3 negative to the power 2 is 9. So if I ask you in the reverse situation, what's the root of 9? Well, it could mean one of two things. The root of 9 could be two things. It could be both 3 and negative 3, because both negative 3 times negative 3 makes 9, and 3 times 3 makes 9. So if I were to kind of get you to think about this a little bit more, or if we were to be solving equations, if I were to give you x squared equals 9, what we're going to have to do is we're going to have to get rid of our squared sign. And our squared sign is what makes something a quadratic. Whenever you see x to the power 2 or x times itself, it gives you a quadratic equation. So this little example is a quadratic equation really quickly. Its growth pattern is a little bit different than a linear growth pattern, which is just x to the power 1. What it will end up doing is, if I were to ask you to solve for x in this situation, what you're going to end up having to do is you would take the root of this and the root of 9, and x would equal positive or negative 3. And this symbol right here means positive or negative 3. Quadratic equations may have 0, 1, 2, or 3 solutions. So quadratic equations may have 1, 2, or 0 solutions. We could get into this more when we get graphing quadratics, and I can kind of explain this a little bit better visually. But here's an example here. In this example right here is a quick example of a quadratic equation with 2 solutions. So this one right here has 2 solutions, and that's an example of a quadratic with 2 solutions. Is when I gave you x plus 3. My pen's deciding to just not work, but my pen's decided to just quit working. And that's an example when, it's because it disconnected. That's an example when, this is an example here of when x is equal to, alright, I'm using my hand to draw the rest of this. So sorry if it gets messy, I'm switching to my hand. Yeah, it's done, okay. So here's an example here of a time when, I guess I'm not drawing over there, when you have 2 solutions, so right over here. This is an example of when you have 2 solutions. We can show you other times where you have no solutions as well. I'll just add another slide here, and I'll just keep. So the square of a number is always positive. Sorry if it's a bit messy, a little bit larger. I'm writing with my hands now. So if x squared, if I give you x squared, it will always be greater than or equal to 0 for all values of x. So if I gave you any value for x, if I gave you that this x was negative 2, x squared is going to be positive 4. And that's kind of important to realize there. So if I gave you 3 negative squared, negative 3 times negative 3 makes 9, and I kind of showed you that on the last side. The inverse of squaring is the square root. Sorry, that's a little bit messy. Is the square root. The symbol for that is a little bit different from the division symbol, but that would be the square root symbol right there. Make sure that you are not making it just a fancy division symbol. If I were to give you a couple examples, let's look at, you could say that if I gave you the root of 4, my battery's just getting low on my iPad. If I gave you the root of 4, this would equal 2. And this is because 2 times 2 equals 4. So you're trying to figure out in these kind of situations what times itself makes 4. And 2 times itself makes 4. It could also be negative 2 as well. Conversely, the other way you could think of this as well is you could also think of this in crazy ways as root of 7 times the root of 7 is going to actually just be equal to 7. In that situation, what you'd end up having is you'd have root 7 squared, and your root and your squared would cancel out, leaving you with just 7 left over. Whenever you have when you have a negative value, if I gave you something, so an example of when there's no solutions. So let me just add quadratics. Sorry, my handwriting's not as neat when I'm using my fingers. Quadratic equations have no solutions if in x squared equals c, if an x squared equals c, c is less than 0. So if I give you a negative number, our quadratic will have no solution. Let me give you an example. If I asked you, if I give you x squared, let me just make that a little bit neater. If I said that x squared equals negative 25, well, the first thing you'd have to do is you'd have to take the root of x squared and the root of 25. Sorry if that's a bit messy. This would be x equals no solution. Because you can't really get a number multiplied by itself to make a negative number. So no number multiplied by itself is going to get a negative number. And these are a special kind of answer called an irrational answer, because it just makes no sense to have something that equals negative 25. So as a result, we have no solution. So this is an example of sometimes when you might have no solution or zero solution. If I were to give you the root of 4, you can simplify root 4 into 2. If I gave you the root, though, of 3, you can't simplify it into a whole number solution. Just like if I gave you the root of 2 or the root of 10, none of these can have a whole number solution. As a result of not having a whole number solution, they are called surds. There are examples of surds. They would end in a repeating or non-repeating decimal. They will go on to infinity, so their answer will continue on forever and ever and ever. You can't represent it in a fraction. It just would kind of be a non-repeating decimal all the way to infinity. So just kind of keep going and going and going and going. We often leave these in exact form, so leave these in surd form. And this ensures that our answer is the most accurate as possible. If I were to give you the root of 25 though, root 25 is not a surd. It's not a surd because we can simplify root 25 into a whole number answer of 5, and that is why it's not a surd, because we can simplify it into a whole number solution. I'm going to kind of get into some of the examples now. So if I gave you x squared equals 25, and I was asking you to find x. So what the first thing I would do is I would take the root on the one side and the root on the other side. Once I've taken the roots of both sides, x becomes, x squared just becomes x, and you are looking now for the root of 25, and because we can, because 25 is not a surd, we can just get it to x equals 5. I'll give you another example of 2x squared equals 18. What we'd end up doing first is we'd end up first dividing both sides by 2. So I'm going to divide this side by 2 and divide this side by 2. Once I've divided both sides by 2, it gets rid of my 2's. That's x squared equals 9. I'm now able to take the root of this side and the root of this side, and then x equals 3. And I look back at my last answer, I'm actually a little bit incorrect. X equals plus or minus 5. And over here, x is plus or minus 3, because it could be positive or negative 3. So my answer could be both positive 3 or negative 3 for what we're squaring to get to 9. And my answer here could be both positive 5 or negative 5 to get to 25. So I just need to remember to do that. And you need to also remember to be including your positive or negative or plus or minus. One more quick example very quickly here. If I give you 1/5 x, yikes, that's a little bit messy. Let's see if we can fix it. X squared equals 20. The first thing I would do to clean this up is I would think about it as, you could kind of combine this into x squared over 5 equals 20. I would then multiply by 5 and multiply by 5. I can then cancel out these two 5's. I'm then able to kind of know that this is equal to, I'm just going to continue over here, x squared equals 20 times 5 is 100. I'm now going to take the root of both sides, and then I get x equals 10, but not just any 10, it's positive or negative 10. Well, I hope that's making sense. If we make it a little bit more complex, if I give you x squared, why are you fighting me on this? Sorry about that. If I give you x squared equals 17, again, we would take the root of x squared and the root of 17. X would equal, and this is where you then write positive or negative root 17, because 17 is a surd. You leave it right there, and you know it's going to be either the positive or the negative value of root 17. So let's look at a little bit different, difficult example. If I give you 3x squared equals 21. So the first thing I would do is divide by 3, divide by 3. My 3's cancel out, leaving me with x squared equals, and 21 divided by 3 makes 7. The next step I do is I take the root of this side and the root of this side. And that leaves me with x equaling positive or negative root 7. And that would be left there. If the question asked you to leave or bring it down into decimal places, and let's say this asked us to do it in 1 decimal place, we would be positive or negative 2.6, and that would be the answer if they ask you to put it in decimal format, and this is if they ask you to leave it in surd format. So just a quick little help for you there. I'm going to keep on clicking along here, so I'll just add one more slide. So if you were given green, squared minus 64 equals 0. We were trying to solve for x. The first thing I would do is I would add 64 and add 64. My 64's cancel out. I have 64 on this side and x squared on this side. I take the root of x squared and the root of 64. X equals positive or negative 8. Fantastic. So the next example we can do is we could do x squared plus 7 equals 0. I subtract 7 and I subtract 7 from this side. Those two 7's cancel out. I have x squared equals negative 7 next. And because we can't take, if I gave you the root of negative 7, that would make no sense. It's not possible to have a number multiplied itself to get negative 7. So as a result of that, we kind of would just say x squared equals, so we'd be here at negative 7, and then you would say, therefore, no possible. Yikes, I've run out of room. No possible solution. Hope that makes sense. So if you get a negative value all by itself on one side and you have x squared on the other and you're trying to root a negative number, it's going to render no possible solution. So the next thing we'll do is let's go for the next one here. I'm just going to add a slide. Oops, I don't know what I just did there. One. So we'll do 3x squared minus 5 equals 7. Oh, and that's supposed to be 3x squared. There we go. So the first thing I'm going to do is I'll add 5 and add 5. These two 5's cancel out. I'm left with 3x squared equals 7 plus 5 makes 12. I'm now going to divide by 3 and divide by 3. My 3's cancel out. X squared equals 12 divided by 3 is 4. The next thing I do is I'm going to just take the root. And let's say that x equals positive or negative 2. In the example in the textbook, it kind of added on a little additional piece of information, and it said that comma x is going to be greater than 0. So if you know that x is going to be greater than 0, and they've told you that x is going to be greater than 0 in their example, well, when you get to your final answer and you're being told that x is going to be either positive or negative 2, but they've told you that x is going to be always greater than 0 for whatever reason, that perhaps we're measuring time or distance, it would make sense to have negative time, you would then just know that x equals 2 since, and by the way, an upside down therefore is since x is going to be greater than 0. Maybe we're measuring time and how many seconds it takes for a cannonball to land if we're thinking about quadratics and the movement of things. Last example, I'll try to write it out just so you'll see it right from the start in the way you saw it before. So 13 minus, let me just go back, 13 minus x squared equals 3, and x will be less than 0. Okay, so there's our whole kind of starting point. So the first thing I'm going to do is I'm going to get started by subtracting 13 from this side and subtracting 13 from this side. These two, 13 minus 13 is 0, and 3 minus 13 gets me to 10. Oh, sorry, that gets me to negative 10. And then I have negative x squared. So far, so good. So what I can do is I have a negative on both sides. So when I have a negative here and a negative here, and especially when you have a negative next to your pronumeral, you're going to want to get rid of that. So we want to move this negative over. So what I'm going to do is to move my negative over, I'm going to multiply by -1. So I'm going to multiply by -1. So I'm multiplying, and I'm going to multiply by -1 on this side too. What you do to one side, you must do the other. A negative times a negative makes a positive, so I have x squared, and a negative multiplied by a negative makes a positive, so I'm at positive 10. Last step I do is I take the root, and I take the root, and x equals positive or negative root 10. Now, in this example, we can go back to this top, and it said that, well, x is going to always be less than 0. So we need to make sure that we are going to pick our right value, because there's two possibilities. We know that x equals negative root 10. And we leave it as a surge, so that way it's the most exact form. And that would be kind of an overview of the what is kind of in the note that I gave you as well. So get going on your practice, and if you want to push yourself a little bit harder, try the extra challenge as well.